Right, I'd like to talk a bit about repurposing the GCC regression suite for using it with LLVM and other compilers. This is sort of a follow-on from a talk Jeremy gave 3 years ago, a longer talk on essentially the same idea, but this is an update on what we've done since. Basically what we want to do is we want to repurpose, in particular, the execute torture test and a bunch of the DG tests as a execution test when bringing up a new backend in LLVM. And unsurprisingly, a lot of tests are basically designed assuming that you're using GCC because that's what the test suite's for. And what we want to do is take the test suite and make it more generic so that LLVM or a third compiler or a fourth compiler can make use of the tests pretty simply. Now, 3 years ago, what Jeremy was talking about is modifying the test suite to absorb a file of tests to ignore, which either when you run tests, you'll either move them out of the source tree or provide some hook that says, yes, I know that there's a DG comment to say that this test is expected to fail, but actually it's not expected to fail because of what compiler I'm using. And that this test, this list of tests would be generated by running the test suite against a assumed to be correct version of that compiler. Now this works quite well in that, assuming that your golden reference compiler is perfect, you'll get a perfect list of tests to ignore. And that means you're not waiting for example, execution tests that will time out. The downside is it really relies on your golden reference compiler being correct, and if it's not, maybe you miss some tests that are useful to you. Now, at the end of Jeremy's talk, there was one bullet point which said something along the lines of, can we add a DG comment that says DG skip if LLVM? And the feedback we got was no. But the idea of adding a bunch of tests for particular GCC features may not be quite so horrible. So since then, we've started taking the same sort of annotations that you have in tests that are things like, I require that this target has an integer that's at least 32 bits, but extending this for a whole set of other attributes such as, does this compiler support attribute leaf? Does this compiler have GCC's dump flags? And things like this. And we've been annotating a fork of the test suite to add these things such that essentially from a checkout of the GCC source and a small patch applied, you can essentially pick up the test suite and use it for whatever compiler supports GCC-like flags. That's one half of what we've done. The other half is a script to actually execute tests. Because if I'm building LLVM, I don't have a GCC build tree, so I can't run make check GCC. So as an alternative, what we have is a Python script which does the same sort of thing as make check GCC does, but also adds a set of extra hooks for instance, if a target needs a GDB server running for actually executing tests, this will manage bringing up servers, mapping ports between instances of the tests and the GDB servers. Oh, a GDB server's failed, I better kill that and relaunch it. And sort of load balance the tests a bunch of set of threads based on, I want 20 tests to be given to each deja GNU instance rather than I want tests that start with A to go to this instance. Currently this script is, we have a set of these scripts, one that is hard-coded to a bunch of different architectures, but our plan is to make that generic so that you just give it a configuration that says, I need a GDB server, I don't need a GDB server, and things will just work. As a demonstration of this, we have a build server running on this URL, which runs, here's an example of doing this for 32-bit RISC-V, whereby I take the top of tree of both GCC and LLVM, build both compilers, and then test both compilers so I can see if something's been checked in overnight. Has something broken each compiler? If something's changed in the assembler and I see that both compilers have failed, I can narrow things down that way. And we have a similar thing for x86 as well. Our fork of the test suite is available at this URL, and on that slide is the set of test results that we got from about, I think it was last Friday. So we've got a bit of a way to go in annotating tests, but we're getting part of the way along there. Once that's got down to near zero, we'll look at what other parts of the test suite might be interesting to execute as well. For instance, at the moment, we're not looking at target-specific tests, which could very well be common amongst a set of compilers, assuming that you've configured them to optimize the same. Going forward, as I say, we'll carry on annotating tests, and then if we find bugs, obviously we'll fix the bugs that the test suite's found. After all, that's its job. And eventually, we would like, if possible, to upstream these changes. After all, most of them are just one-line comments adding, DG skip if this attribute's not supported. If not, the patch is quite small, so we should be able to have something automatically rebase these to pick up new tests automatically. Thank you.
This may be a cheeky question. Have you looked at using LLVM's test suite to test GCC? Like reversing the... Was that
no, but once... well, there's no reason we can't. We just haven't. Yeah. If Jeremy will allocate some time for me to look at that, I'm sure that...
Actually running the LLVM test suite with GCC is pretty trivial because they don't have Deja GNU. So you run a Python script and you just tell it, use this compiler as the compiler for the tests. I've no idea what the results would be like, but it's much easier to do the opposite of this.
Isn't the point of this, though, that most of the LLVM test suite is testing manipulation of LLVM internal representation? It doesn't have so much in the way of tests that test execution, compilation and execution all the way through to target code, as GCC does.
Depends which test suite you're looking at, because there's two LLVM tests. There's the lit tests, which live in the LLVM tree, and there's this LLVM nightly test system, which is more, here are some large programs that you can benchmark and see how execution time compares against different builds of the compiler.
I'm curious if you found, in analyzing the failures, if you found tests in the GCC test suite that intentionally exercise undefined behavior, and if you've seen differences between LLVM behavior and GCC behavior for those tests.
I haven't, but I haven't been the one that's been analyzing the tests. My colleague Ed, who's been doing the filming in the other room, has been really analyzing the tests as we've gone along, so I'd find him and ask him that question.
Just one comment. I haven't used the GCC test suite as a whole to test LLVM, but what I have done is use GCC's ABI compatibility tests to verify ABI compatibility between GCC and LLVM, which is quite important topic to get right. And I was bitten by the same thing, that some of the tests in there used like data types that LLVM didn't have, attributes that LLVM didn't have. So having these types of attributes would be great.
Obviously, for the ABI compatibility tests, it's important that they can be restricted to appropriate features because they can be used for lots of compilers. Like, I once used them some years ago to test compatibility with ARM's compiler when implementing the ARM hard float ABI, for example.